Doubt my favourite question on the paper. So for question 5, we are asked to using some exact values here. So first things first is to say, is the first mark, show that the exact value of cos b can be written as 2 over root 5. So whenever I'm doing an exact value problem, I always want to go back to my right angled triangles, okay? So let's draw out my right angled triangle. This is the right angled triangle for b. And I'm told in the question that sine b is 1 over root 5. So if sine b, which is, if we remember from GCSE, opposite over hypotenuse, is equal to 1 over root 5. So the opposite in this triangle is 1 and the hypotenuse is root 5. We can then read from here. So Pythagoras states that 1 squared plus whatever this adjacent side is squared is equal to root 5 squared. Now you don't need to show this workings. You can, if you know it's what it's going to be, you can just work it out straight away. But we've got 5 equals a squared plus 1. So obviously a squared is equal to 4. So a is equal to 2. So once you've got that right angled triangle, you can then go, oh, GCSE knowledge, cos of b is adjacent over hypotenuse. And fortunately, that is 2 over root 5, which is what we've been asked to show. Now, the primary solution in the mark scheme is actually using sine squared plus cos squared equals 1. You can do that if you like, but I think this is just a really quick way that works for all of the triangles, all the sorts of questions you might be asked. Now, we've been asked to do the hence show the exact value of sine 2b. So I thought I'd just very quickly grab the trig identity for sine 2b. So this is when effectively you've got to think that a and b are the same value to give us the 2. Okay, so it's going to be sine 2b is equal to sine b cos b, and it's plus together, so plus cos b sine b. So just reading exactly what I've got up here, sine b is 1 over root 5, cos b is 2 over root 5, and they are being multiplied together, plus, and it's the same thing again, and if you wanted to just write it out as 2 sine b cos b, that's absolutely fine, but I'm just going to, for completeness, just write this out in full. So 1 times 2 on the top gives me 2 over root 5 times root 5, which is 5, so 2/5 plus another 2/5 equals 4/5. So that's me showing there the exact value of sine 2b is 4/5. So I've used the trig identity and just substituted into it. Now for part B, we now need to also be not only using our B triangle, but also our A triangle. So I'm just going to remove the workings for part A, part 2 there. And let's draw out the other triangle. So this is another right angle triangle. It's a different one. It's not, as some students want to do, an A up there. It's a different triangle for A. But again, we've been told that sine A is equal to, and we know it's opposite over hypotenuse, so opposite over hypotenuse of root 5 over 3. So this time root 5, it's a right angle triangle, over 3. So bit of Pythagoras again, 3 squared equals root 5 squared plus whatever the adjacent side is squared. 9 equals root 5 squared, which is 5, plus a squared. So once again, a squared equals 4, so a is equal to 2. And that's just important for the rest of what we're going to do. So let's just write down that cos of a is the adjacent over the hypotenuse, which is 2/3. Okay, so that's a bit of extra to start us off with B part 1. So show that the exact value of sine a minus b can be written as some value of p, lots of 5 minus root 5. So we're doing sine of something minus something, so the sign stays the same. So sine of a minus b, and it's very nice of the examiner to leave it in the same form as our formula book. So it's sine a cos b minus cos a sine b. So just reading, literally reading from everything I've got up here, with the exception of the fact my 5s look like 3s, which is not massively ideal. So sine a is root 5 over 3. That was given already. Cos b is 2 over root 5 minus cos A is 2/3, sine B is 1 over root 5. So let's tidy up what we've got. We've got 2 root 5 over 3 root 5 minus 2 over 3 root 5. Now, we've got a common denominator in here, so let's utilise that. So I've got 2 root 5 minus 2 over 3 root 5. Now, that's obviously not in the right format just yet, so we want to remove the denominator. We're looking for something without a fraction, so let's rationalise. If we times top and bottom by root 5, we're going to, this term here is going to become 2 times 5, which is 10, minus 2 root 5, and the denominator here is going to become 3 times 5, which is 15. So I'm just going to scroll to give myself a little bit more room here, but we can still see where we're going. So we want to take a rational number out the front to be leaving us with a 2, 5. So let's just split this up into its 2 fractional parts, just to be really obvious what's going on here. So we can take out a factor of 2/15. Now 2/15 times what gives me 10/15? Fortunately it's 5 minus the root 5. And that's what we were being asked to show. So P is 2/15 there. Now part 2, B part 2, we can see the question in here, so I won't do too much scrolling around, but let's just draw a line here. Don't do this in your exam, but obviously make use of the space you've been given. So this time we've got to do cos of A minus B. And I am going to scroll up a little bit more actually, just so that we've got all those values of sine and cos involved. So this is where these signs are really important, because you've got a minus here, which means we've got a plus in the identity, because it's the opposite sign in the cos one. So it's cos A, cos B, plus sine A, sine B. So then again, just reading everything that we've already got it all over here. So cos A was 2/3 and cos B was 2 over root 5. Sine A was root 5 over 3 and sine B was 1 over root 5. So very, very similar to part 1 of B actually. Just working this through again, I've got 4 over 3 root 5 plus root 5 over 3 root 5. Once again, let's give it a common denominator. So we've got 4 plus root 5 all over 3 root 5. We're looking to formulate it into this form. So again, rationalise the denominator. Personally, I'm not a massive fan of this second part, because I feel like they're testing exactly the same skills a second time round, which doesn't really seem fair, because obviously if you weren't sure how to do it first time, you're not going to be able to do it the second time. So personally, not a massive fan of this final part, but really like the overall question. So 4 root 15 plus 5 over 15 there. And once again, we're just trying to work out what our rational numbers are here. So our R is going to be, let's just divide these up. So 4 root 5 over 15 plus 5/15. So 4 root 5 can't be simplified. That's your S, if you like. S is the 4 root 5, so that bit there is your S. And obviously this bit can be simplified a bit, so let's do it in the way they wanted. So the number first, 1/3 plus 4/15 of root 5. And that's your final 3 marks. So really, for this question, an awful lot of marks available just for making sure that you've got your triangles sorted, and then you can find all those exact values nice and speedily.